Hey guys, this is Richard from Solder. So this is the first episode of Solder by Example, where we take real-life examples and see how can you solder to enrich and make your life easier while building these real-life applications. So in this first episode, we're going to start from building an escrow system with Solder and your basic Solana stack. And we can see how Solder integrates seamlessly with the existing and latest Solana stack. So let's dive into it. So we are building a swapping escrow that will allow user to deposit a certain token and request for from another user. For example, user A will deposit X amount of token A and request for Y amount of token B. Then user B comes around, sees the escrow, wants to accept the terms. So the program will allow this user B to transfer the Y amount of token B to user A, while at the same time taking what's inside that escrows. So this will create sort of a swapping effect. So we will build the program using Anchor, though we will not go into detail of how is that built, just a quick scan of what's inside the program. And also we will build a front end that will showcase all these escrows and how we can make and take using Solana Kit and Solana Kite. Again, this will not be a deep dive of the front end and the programs, and this video will mostly be focused on Solder itself. So Solder will take care of the indexing and listing all these escrows so that we don't have to repeatedly call RPCs to search, to query, and to sort them in whatever order. So that's where Solder comes in. So this tutorial will again not cover the program and front-end details. It will be mostly focused on the Solder implementation. So I will have to assume that you have installed your Anchor program and also your front end. You have set them all up, and you can clone it up from our GitHub, so you don't have to write them from scratch. So let's get diving. So if you see our program here, we have three major instructions: make, refund, and take. We'll be only focusing on two instructions here, which is the make and take for simplicity reasons. And as you can see here, the function is very simple. User will deposit a certain amount of tokens, it will transfer to the vault, and then the key here is that this program will emit an event right here. Make event. So this will emit the event onto the transaction. It will attach like a label so that our indexer can pick it up and list it on our database. This is similar to the take function, where the user B will take the tokens from the vault and also transfer the requested amount of token to user A, and also this will also emit an event. This is the key to the system, the whole thing. And we've deployed this on the local net. So you can see here we have Surfball running with a smart contract live. So we can actually make use of it in our local computer. We're having to deploy to DevNet or mainnet. Okay, next we have our front-end system. So we have set up a clean front-end here so that we can easily work from there. So this, you can connect your wallet, and what this will do is that this will list all the escrow. So you can see here no escrows are found. This is where Solder will come in and list all of them for you. Right, so this is the front end that we're gonna have. So this list to list all the escrow right here is what Solder is going to help you do, right? So as you listen to the events, it will get recorded to the database, and we can call them via classic REST APIs, which is very simple, and you don't have to go back and forth with RPCs endpoints to do that. So let's get started. So to start building with Solder, all you have to do is just run npx create Solder. What this will do is that this will give you an entire Solder application right off the box. Let's call it Escrow Indexer. Just create there. Yes. Start project with pnpm, yes. No, we don't need cloud wallets currently, so we will skip that step and we'll just wait until the installation is done. Okay, so now we have finished the installation. Let's start cooking with Solder. So let's go to the folder by following the instruction here, cd escrow indexer. Then what we'll do here is that we'll just open it in cursor. So this should give you a fully scaffolded Solder application that you can start working from. All right, so first things first, let's configure our RPC endpoints and also our database configuration, like just set up a database link so that we can start working with Solder. Note that before you work with Solder, you have to make sure you have an RPC ready for any local development and also have a database link ready. They're not very hard to set up, and we will attach links below on how to set up database and Surfball, your local RPC. So here we set up an env file. Just do that really quickly. Then we just have to follow this configuration right here. But we don't use the default because we want to connect to Surfball. We also want to use a different database. So I have a configuration preset right here. So let me paste it in a bit. Okay, so I've set up our database and also our RPC URL, which points to our Surfball instance, which is running in local. So the next step that we have to do is that we have to fetch the ID of the program. You can easily just search it right here. When you deploy with Surfball, they will include as a JSON file. So you just have to copy it over and paste it somewhere here. Just paste it besides the example IDL and you'll be good. Then we have to convert them to TypeScript so that Solder can pick it up easily. This is very simple to do. So here we have pasted our Escrow's IDL. So what I'm going to do now is convert this into TypeScript format. The reason why we have to convert the TypeScript format is that so that Solder can pick up on the type safety. And this might sound hard, but it's not really hard to do at all, because we have provided a tooling that do exactly just that. So all I have to do is run pnpm, run IDL to TypeScript. Then we just paste the path here. There you go, it's done. Then we have a TypeScript version of our IDL, ready to go. Let me zoom that out real quick. It's the same format, just that it's wrapped on TypeScript and contains some type enforcement right there. Okay, so the next step, what we have to do is that we have to set up our database so that we can have these events stored in one place. So in this case, we will just want to store the escrows that have been created, and that's it. And also maybe a way to delete them. So this is very easy. Solder provides with you database definition, API generation at the same time. As you can see here, in the Solder default setup, we have the setup for pump.funds trade events. So let's replace it with our own escrow definitions. Let me paste some code so that you don't have to watch me type. Okay, so I've set up our database schema here. So what this will do is that we will just define the columns of the table that we want to use. Right, so this just indicates the different data types. Integer, varchar, which means string. Varchar and text are doing similar things. They are still string as well. And note that in here, we use the address as the primary key because for every escrow instance, they will have a different PDA. So that's what we are going to use as the primary key, which is the main differentiator of each column on the table. And if you notice here in the bottom here, we have some other configurations. What this does is that this will define the API generation that Solder will do for you. So in these operations, we do list, which is true. List means we can list all of them all at once. So it's true because we need that feature. Read is for more specific reads, which is true as well. And we don't want people to actually create and update this table without interacting with the contract. So we just disable them for security reasons so that people don't have a way to do that. And we set deleted true because when we take the escrow, this will then delete the entry on the table. So then here, all you have to do is just change to escrows. Then you just change it to escrows as well. And you're good. You just have set up your database. So let's go to the indexer next. I will show you how simple it is to set up an indexing pipeline for your events in Solder. So the next step here is to set up the indexing logic. So this is still in the same project, Solder project. Then in here, we should have an example for pump.fun. But in this case, I took the liberty to update it to our needs, which is the escrow make event. So let me go through the on event handler line by line. So on event will get triggered when the event that you specify gets fired by the smart contract, by the program. So in here, you see that we specify the type as well of the IDL because we define a TypeScript that will enforce type safety. So you cannot really put the wrong types there. And when you do make, you specify the make event here so that it will get specified to the event that you want to use. Specify the IDL here, the event that you want to listen to, and define the callback that you want to do. So this could be anything. This could be sending a message to your Telegram bot. This could be sending a message to your Slack in your company account, or just piping into the database. And that's what we will do currently, putting it in the database. So as you can see here, we are inserting to the escrows table. So we insert information such as the maker, the escrow address, the mint, A, B, C, receive amount, created, updated. You also have to insert the escrow address, so that because that's our primary key, and we're good. So that's our indexer, and we can start to run this. So we can just run it by running pnpm run dev. This will give you a nice UI, and this is indexing as we speak. And now these are capturing events that will happen on the blockchain, which in this case is just our local net setup that has been handled by Surfpool. Let's go to front end next. So I've provided a hook that acts as a similar hook as the useQuery hook from React Query. So what this will do is that it will provide you with fetching, async logic with loading state and error state, so you can easily render them in the UI. So in this case, we are fetching from the REST API that has been generated by Solder. If you notice, we didn't have to generate any REST API via Solder because it has been auto-generated by the Solder framework itself. So let's try to implement the API fetching in this hook. In here, we just fetch like usual, like your typical REST API. You can use Axios, you can use fetch, you can use whatever library you desire. And then we just transform it to the data that our UI needs. So in this case, just like this. And done. That's how you can index data and fetch them in the front end. So let's test them out. Okay, so if you go back to the app that we have just now, you can see that it finally shows the escrow that we have just created. So you can see here that the implementation fetches the data from our solder server. You can see here that the data has been successfully fetched, and it keeps the fetching so that we can update as we create more and more escrows. So let's recap. We have built a database schema and API generation with Solder for our created escrows. We have built an event indexing handler for my event, which happens when we make the escrows, and pipe them to the database so that our database has all the information of all the escrows that we have created. And also, we have retrieved data from the server via REST API calls, which were auto-generated by Solder and show it to the front end. So you can see here, Solder can apply to your escrow application needs, and it can really be used on real-life situations and production environments. So thanks for tuning by, and stay tuned for the next episode of Solder by Example. Cheers!